Hi, my name is Manish Kumar Nayak. I am from IIT Kharagpur, pursuing my PhD. So today I will share the simulation of two-stage hot rolling schematic. This is the schematic of hot rolling process where the stock is coming out from the furnace and then it is cooled down by the descaler first stage, then passed through the roller, and again in second stage it is cooled down by the scaler and then again in second it is rolled by the roller. So this is the schematic. Now uh, this is the process parameter which we have to follow. Like initial thickness we have to take the 57 mm. Thickness at the first stage is 22 mm. Now roll diameter is given, roll speed is given, friction coefficient at roll work material interface is given, d scalar contact, thermal contact conductance, initial length of the stock, convective heat transfer, initial temperature of the stock, initial roll temperature, ambient temperature, distance traveled by the stock, distance from center of descaler to center of first roller, and the length of descaling unit is 80 mm. So these are the process parameter, and some of the process matter parameter which is not given here and possibly we will use in our simulation. So we will assume that values in the simulation. Now moving to my simulations. So because I had simulated four hot rolling and for initial temperature of stock 1000, 1050, 1100 and 1150. Now I will show one simulation that is of 1000 now, and we will see the how the results are there. So let's open the Abacus CAE file for 1000 initial temperature of the stock. So let it get open, and yeah, so it came here. So now we can see here already the parts are there. So let me discuss what are the parts we include here. First is descaler, second roller, and third is stock. Now let's go to descaler. It is already given the dimensions in the process what we have to take parameters and the dimensions. So they are descaler, but here we have taken the arbitrary thickness of the um, your descaler. It will not affect anything, just for the sake of now second is roller. This is the roller, and we had taken the thickness considering the diffusion length, uh, and it is around 35 mm thickness of this roller. uh, Again second third what is stock. So this is my stock, and you can see in starting of the position the thickness of the stock is getting decreased by, because when it get inside the roller, so if the thickness is higher in the in initial point, then the crushing will take place, which will affect my simulation part. And in practical purpose also, it is not recommended to use directly more thickened part in the initial point. So now moving to second part, that is property. We have to assign the property, material property to all the parts here. So let's see what are the proper material parts we had defined. Like first is roller material and second is the stock material. So roller material, let me show you the properties what I had taken, material behaviors, that is conductivity, density, elastic properties, and specific heat. And for stock material, I had defined that conductivity of the material, density, elastic, expansion, inelastic heat fraction, plastic, and then specific heat. Now let me go to section manager. Here we have to um, here we have to uh, name the section like stock material, like descaler section is there. So I have taken the material for descaler stock material only. Now for roller section, we have defined the roller material what we have defined earlier. And similarly for stock section, we have taken the stock material as the material. Now we have to assign these sections to all the parts. Like for this stock, I had assigned the stock section which I defined before. Similarly for roller also, we had assigned roller section, that is solid and homogeneous. Now moving to next part, this is assembly. Here we will create all the instances, like instance option is here. We can create instance and bring all the parts here, and we can, by using this translate instance option, we can translate all the uh, instances in their respective position as per the given in the schematics. So from this we can see that my stock, this stock is around 1300 750 far from the first roller, and the distance between two rollers is around 5500 mm. So with the use of these instances we can uh, arrange the instance as per the schematics. Now coming to step module, here we will define like how many steps it will take to roll the for roll up to second stage. So I had defined in 4 stages. There is step 1, it will reach to the roller 1, then the rolling will take place in first stage. Then again after coming out the rolling one, step 3, it will reach to uh, second roller, and then second rolling will take place. And these are the time I had assigned, that is first it will, actually I had considered my roll stock speed 1000 per second. So, as per that, it will take 13 seconds, 13.4 seconds, 74 second around to reach the um, to reach my first roller. And like that we had calculated manually this time, and after simulation we found that it is almost okay. Now second is the we have to define the field output requirements. What are the field output we required? So here I had taken the interval of 1000, and the whatever the field output you need, you can define it here. Like I need my forces like reaction forces and reaction moments, so I had selected these two. Similarly, we if you we have to define a history output of the history output also. So like here we had selected only energy, it is by default it was selected, so we need that much only. Now coming to next module, interaction, which is the one of the most important part. And here let's go to interaction manager. Let me show you how what are the we had defined here, like roller convection and roller convection 2. Here one is defined for the first stage, that is roller and descaler, and 2 number is defined for the second descaler and second roller. So we had defined the convection for both the rollers. We had defined the radiation for both the rollers. Now we had defined roller stock interaction for the first stage and roller stock interaction for the second stage. Then descaler stock for the first stage and descaler stock interaction for the second stage. Then we had defined the stock convection and stock radiation. Let me show you the values one by one. Like roller convection, we had taken the film coefficient 0.085 and sink temperature is 40. Similarly for roller 2 also we had taken the same values. Now for radiation we had taken emissivity 0.83 and ambient temperature as 40. Similarly for roller 2. Now coming to roller stock interaction. So here we had defined the mechanical constant formulation as penalty contact method, and we had defined the contact interaction property as roller stock interaction property. Uh, so okay. Similarly for same thing I had defined for roller stock for second stage also. Now coming to roller stock descaler. So we can see here I have taken the mechanical constraints, kinematic and stock descaler we have defined over here also. Coming to stock convection, same thing like film coefficient and sink temperature and stock radiation. Now moving to next part, interaction property manager. I had shown you before we have to define the take the while defining the interaction manager interactions we have to take the interaction property manager also. So we have defined the interaction property here also here. So first is roller stock interaction property like film coefficient here, tangential behavior I had taken, normal behavior I had taken, thermal conductance I had taken, and heat generation we had taken. Now for stock descaler interaction property, we had taken only thermal conductance because descaler because the contact between descaler and stock is only for the conductance, no mechanical changes are happening there. Now next is constraint manager. So in the starting when we are drawing the geometries or taking the drawing the parts, so there we had considered the deformable property, but here as the descaler and roller rigid body are rigid, we will give the constraint manager as rigid body for this descaler 1, descaler 2 and rigid roller 1 and roller 2. Now coming to next module, load. This is also very important in after interaction. We have to uh, here define the boundary conditions. Now see descaler boundary condition, descaler first. We had encasted the descaler 1 and descaler 2. Let me show you. See here the blue tick is there. So encasted we had restricted all the motion of the descaler. Similarly for descaler 2 also. Now descaler temperature for 1 is there. So what is the temperature we have taken? 40. Similarly for descaler temperature 2 also. Roller angular velocity we had taken as 1.82. Okay, so similarly roller angular velocity for second roller also we had taken 1.8. Now roller translation. Now roller translation is restricted in x and y direction. It will only rotate. So u and uts we had taken as 0. Similarly for roller translation 2 also u1 and u2 will be 0. Now stock symmetry condition is that it will not move in the perpendicular direction to the movement, that is in y direction. So here also I can show you we have taken the displacement and y direction is 0. Now we have to define the stock velocity. Like stock velocity we have taken 1000 mm per second, as I told you before also. Similarly for stock velocity when we started the second step 3 after coming out the roller 1. So there also we have taken the 1000 mm per second. Now after that we have to define the predefined uh, fields. Now predefined fields are roller initial temperature for 1 and 2 both and stock initial temperature. Roller initial temperature is taken as 70 for both the rollers and stock initial temperature is taken here as 1000. As I told so showed you in the starting only I had changed initial temperature 1000 for various temperatures are there, and according to we had taken the data for separating forces and torques. Now next module is your meshing. So here we will mesh the parts. Like first we will go to mesh controls. Sorry, we have to select the part here first. Like roller, here it is showing. So mesh controls. Control here we will for roller we will take technique we will use sweep and element shape should be quad. And then we will mesh and then element type. Sorry, element type. So we will select the region, this region, and then after we will like let me do the done. sorry, like element type. So we will select here explicit element library and linear as geometric order and families coupled temperature displacement. So all the element controls are like CPE 4RT for all descaler also, roller also, and stop also. Okay. So after that we will seed edges. Okay. So already I had seed the edges. So I had taken 100 number of parts for this, and for descaler we had defined as per the size. I had taken the 10 or 10 I had taken size of the elements in the uh, stock part. Can I can show you? See now, after meshing all the parts, we will go for job direct, and we will create our job. We will name it, and after that we will submit the part. Now if you want a little bit faster and some high precision, you can go here and you can change the precision from single to double analysis packager, and here from here single to full. Similarly, if you want, if your laptop is having multiple cores, then you can use multiple processor. I directly used 8 core. Uh, After that, you can submit. Then we can monitor the whatever the things are there. We can monitor it like it has already been completed here. So you can see. So it for 21.59 second of simulation, it took around like I had started 8:54 and it completed. Sorry. When I started, so I started at around 12 o'clock and it completed 1:20. Means one simulation it took 1.5 hour approx. So after that we can go in results. So I don't know why it is taking so much time. Yeah, it came. So here you can see this is the uh, results. I can show you how my results are, means how the reduction is taking place of the. So this is on my case. I will show you the temperature. Actually it will be much better. uh, so nodal temperature, let me search down the this font. So we will go to viewport, viewport annotations like triad. We can legend set font. I can select 8 so it can become small. Okay, so okay, so now I think we can see it clearly. uh, Here we can see the step. It will show which step it is there when the movement will take place of this stock, then step time. So let me go for frame selector. Now I will start from the one. See, this is my stock and this will move. As I am moving the frame selector, it is moving. First it is passing through the descaler one, then roller one. Here we can see that reduction is taking place at roller 1, then passing through the descaler 2, and then passing through the roller 2. So this is the uh, simulation part. We can animate this also, these things. Now let me see the let me do the mirror imaging so that we can get a proper view. So for that, uh, let me define first uh, local coordinate system. I will take 3 node rectangular. Now we have to take the, let me take this point. So I will take 3 nodes. So let me first continue, select the node to be origin. I will take this point as an origin in my stock, then this point as X and this point as Y. Now we can see here we have defined our local coordinate system. Now we will go to uh, viewport annotation, sorry, we will go to ODB display options. Okay, so we will go mirror pattern. We will select here mirror CSYS and we will mirror it along XZ plane. Now apply. So okay, it came. Okay, now we will get us some proper view. So this is my, now two rollers are there in opposite direction. Similarly for my descaler also, let me zoom it and show you every part. So this is my descaler. Let me bring the frame selector. Let me pass the stock from this. See, it is passing. So let me show the temperature variation also. So one by one we can see. So we can see here some temperature variation is taking place. Let me zoom and show you. Okay, so see the temperature variation taking place due to the conductance through the descaler. Now let me zoom in the uh, roller area. Let me bring my this. So see here the reduction is taking place now very nicely. Okay, so we can see here from both the sides how the reduction is taking place. Okay, so similarly for descaler 2 also, let me zoom into it and show you. It is also passing through the descaler. Okay, so it is very nicely passing through the descaler part also. Now here also the cooling is taking place. Let me zoom it and show you. See, it is taking place. So at last we have the, it will pass through the roller 2. So let me show the frame selector. So see, now here what happened, already the reduction has taken place in the first roller. So here only the small amount of torque and separating force is required. Okay, but still the temperature is slowing down here. Okay, so this is the simulation part. Now let me go for some results. So for results, let me go to tools, XY data. We will go create and then ODB filled out. Continue. So first of all, we will see the temperature variation. Okay, how the nodal temperature. So you will select unique nodal. Let me select the nodal temperature and then element we have to select it. Uh, let me go. Let me first fit the things. Okay, so let me now select the points. Uh, we are taking the temperature. So let me first zoom it. Okay, so let me select the nodes. Like I select one node here at the surface and one node here at the midpoint of the stock. Okay, so now edit selection is just taken the two nodes. Now I will plot. So it will take some time to plot the things. It is processing, accumulating all the data because already the simulation has been done. So this is the temperature of at the surface and at the midpoint at two nodes. How it is showing the variation when it is passing through the descaler first and then roller first, then descaler 2 and roller 2. So it will show the results for that temperature variation in the whole process. So it is processing. Let's wait for 1 minute. Actually, laptop processor is playing a good role here. If laptop processor is faster, then it will give the results faster. So for two nodes, it is taking this much time. Okay, so here we got the results. Let me show you the results. Temperature and time. So total is around 21 or 22 seconds it has taken the time. Now you can see that this red color is the midpoint of the stroke. It is remaining constant till 13 seconds almost, and then little bit higher in the when it has entered the roller. Now it is decreasing due to the convection radiation and the descaler after the first roller. Now the most important and most uh, interesting part in the surface. We can see here when it came to the first descaler, it the temperature came down. Then again it is increasing due to the internal heat generation due to the, and then when it has came down first order, suddenly the temperature came very steeply down, and then again increasing, and then again it has passed through the descaler 2, again it has temperature came down, and again little bit increasing due to heat generation from the center, and again it came down due to the second roller stage. So here the simulation has been done in very correct manner. This shows that my simulation is correct from the all points. This is the temperature. Let me show you separating force also. Like I will select here RF2. This will give me the separating force. Let me select the nodes. Uh, okay, so let me select this node, first roller node, and let me show the results. Edit selection. It has taken one node. Now I will plot it. Hmm. Okay, so we got the results. Here we can see that our forces are, this is separating force. This is showing the negative magnitude due to the reaction. It is reaction is downward, so that's why. So the magnitude is for useful for us. Like here we can see it is around 35,000, more than 35,000 maximum. Force is separating force has been applied, which is a huge number. We can see only that as we had uh, seen in the roller one. So at the this is the stage when the rolling is taking place. At that time only huge amount of separating force has been applied. Okay, so similarly we can see for uh, RM3 like torque also. So let me show you that also. So torque, same node I will select, and again let me plot it. Torque, okay. So let me see. Already the node has been selected before, so in same node only I will plot that reaction torque or reaction moment also. Reaction moment, that is Rm3, it is moment along the z axis. Okay, so we will see the what is the reaction moment. So let it process. Yeah, it is completed. So let me dismiss now. So this is the moment. Now you can see that it is in the power of E6. So I think it is more than 15 lakh or something. And this is in Newton mm. Okay. So when the stock is passing through the roller one, see the uh, very high amount of torque required to do this process. So this is the things which I had done here. You can try also sometime. The problem when I am doing this, there are so many problems I faced. First of all, sometimes in the interaction property, if you do not define the interaction properly, you will get so many errors. And even after it will run also, it will not go, the stock will not move properly as you want. So please define the interaction properties very carefully, because it took me around 1 or 2 days to just correct my interactions of stock and descaler and roller. So this is the problem I faced in the simulation of this hot rolling process. And uh, after that it is okay. Okay, so this here I will end my video. Thank you.